Hello, everybody. Just gonna wait a couple more minutes before I start talking to make sure we start at the official time. So I should just mention some logistics now before we get started, but the way this is going to work is I'm going to walk through fairly slowly the processes of setting up a Linux virtual environment, and there's a number of challenges that were mentioned in the advertisements for this event that we're going to work through. But at any point, if you guys feel like you have a question or you want to stop for more clarification, you can either send a message in the Twitch chat, or I'm also listening into the voice channel stream. Now, the voices won't be heard on the stream. That'll just be in my earphones. So if you have a question that you want to ask that you can't easily articulate into text, just feel free to chat away in there. So please do. This is supposed to be very interactive. I want people to follow along and work along while we do this so that they can also get their own, you guys can all have your own environment set up for participation. Thanks, Stephen, for posting that. There's a link now in the chat for the Discord if you're not on it. So I want this to be really hands-on so you guys can get this environment set up so that when we start doing the UMass CTF, or even if you're not participating in the CTF, if you just want to have a Linux environment for whatever computer science reason you want it, you'll have that set to go. You don't have to go back and watch the video and spend twice as much time doing this. You can just do it now and get it done. It's fairly easy too. The stuff, we're going to be moving very slowly, and everyone should have a wonderful time. So I guess let's get started. There's a couple things we need to download. Exactly a couple. First, we need to download VirtualBox. There's two primary virtualization software packages. VirtualBox is the free open source one. There's by Oracle. There's also VMware, which we're not going to be using now, but you can look into that if you want an alternative. It's somewhat powerful in some ways, but I won't get into that now. So with VirtualBox, what this will allow us to do is quite literally run virtual environments inside of our computer. So if you're on Mac, you can download here. There's the OS X host. There's a DMG package, and if you're on Windows, you can download the exe. It's only 103 megabytes, so you can get that going now. And I also want, in the background, while we set up VirtualBox, I want you to start another download. So if you navigate to, first just Google VirtualBox. It should be the first result, but it's just virtualbox.org. And you can navigate, so I think this will take you, yep. Thanks, Stephen, again. So if you navigate to virtualbox.org, you can just click on the huge download button. It'll take you to this page I was at. Download your respective package. I'm going to assume that nobody's actually running Linux already as the primary operating system, since this is a little bit below your level then, if that's the case. But for those Windows and Mac users, download your respective package. And also on Lubuntu.me, you can click Get Lubuntu, and we're going to download this desktop 64-bit. And I don't have this downloaded, so I'm going to actually download this. It's a couple gigabytes, so we'll wait a little bit because it should take some time, but hopefully everyone can get this going. So what Lubuntu is it's a lightweight Ubuntu, however you want to pronounce it, distribution. For those who are maybe a little bit familiar with Linux, maybe you've heard of Ubuntu. It's probably the most popular and widely supported Linux distribution. The idea of us using this now is it's very lightweight, and it kind of comes as a minimal package with no bells and whistles, and we can add upon it as we go and as we need. So not only is it a smaller download to start, we can also kind of run this lightweight system inside of our systems without having to worry about too much bloatware, anything really slowing us down, like any fancy GUI environments and such. So actually, I thought this download was only a gigabyte. It looks like it's 2. That's interesting. But now, so everyone's probably had their Windows hosts at exe or their OSX DMG saved by now. And one thing, since we're security, I want to walk through this really quickly. Sometimes you can trust downloading things off the internet, but especially when you're running things that'll be interacting with your kernel, like VirtualBox will, you're giving it all of the permissions, right? So you want to make sure that this isn't malware. You want to make sure this is good stuff you want to be running. So often, along with software, you'll find SHA-256 checksums. So if you want to go ahead and look at these, there's a big list of it. But essentially, each one of these long strings is the hash value of that software we've downloaded. This cryptographic hash is essentially a one-way function. You can think of it. It's computationally infeasible to go the other way. So when we have a chunk of software and we run this hash operation over it, we'll get this nice little string. It's exactly 256 bits long. And with this 256-bit character, we'll have a very hard time, A, finding out what this string came from, B, most importantly, finding two types of software that are different but result in the same hash. So the point of checking this hash against the software we've downloaded is to make sure that the software that we've been provided by Oracle that we've downloaded hasn't been modified in any malicious or even unintentional ways. So once we've downloaded VirtualBox in Windows, if you open up your command prompt, there's a built-in utility we can use to actually verify this. So we've downloaded, so if we actually cd to downloads, we've already downloaded our VirtualBox exe. So to find out what that SHA-256 hash value of this is, we can use cert util. So it's lowercase cert, capital U, TIL, and we can hash this file. Is that big enough? Yeah, I think that's big enough. I can make that larger if anybody wants it to be, but I think this is fine. So we can hash this file, and the file we want to hash is just VirtualBox, and you can use tab to tab complete that after you've typed in a few characters, and this should tell us a SHA-256 value. So here we see that VirtualBox 6. Okay, ask away.
Oh yeah. You know the cert util function? Is there an equivalent for Mac?
Yeah, so actually, I think Mac will have, since Mac is Unix based, so it's actually much closer to being a sort of a Linux distribution than Windows is in a sense. So it might have, if you open up your Bash terminal, you can try typing in SHA-256 sum, and you can let me know if that does anything. I should say for those listening, not in the Discord, somebody asked if Mac has an equivalent hash function built in, and it might or might not. I'm not too familiar with Mac. So in fact, we can look this up, right? So if we go Mac, did that work?
It didn't.
Okay, so we found an article on the interwebs here. SHA-sum. Okay, here, try this. SHA-sum shum-a 256, and then the file name, and hopefully that'll do the same thing.
Okay, thank you.
Yep. So again, if you're on Mac, you can use the SHA-sum tool. On Windows, we can use this guy right here, and we've already done it. We've gotten this hash here. So we can verify against this list that they've provided to make sure this is the right one. So we're looking for 6.1 Windows, which I could Control F for this, but it's right here. And we see that this actually is, this isn't SHA-256, that's a SHA-1 hash. I'm like, wait a minute, this isn't long enough. So we have to actually pass in also the parameter SHA-256 at the end. That's funny. So same command except with SHA-256 to specify the exact hash algorithm we want to use. And we see that this string, we can actually copy this just to verify. And there we see that this matched. So we can trust the software. And you can actually do the same thing once you finish downloading Ubuntu. They have provided SHA-256 sums here. So you can do the same thing. It looks like my download is completed. So I'm going to go ahead and do the same exact command. We can navigate back to here and go to Ubuntu and SHA-256. that was an uppercase. That might matter. It looks like it doesn't. This might take a minute. Again, we're hashing a 2 GB large file. So yeah, it took a few seconds there. It might take longer if people are on laptops, slower hardware. But we've got our value, and we can verify this. It looks like it's the same, but again, we can just copy it just to make sure. Yeah. So we've downloaded 2 safe files, and we're going to proceed to run this. So I'm just going to wait a second. I'm going to answer some questions in the chat while I wait for people to catch up to this point. Somebody asks, if an attacker was able to compromise the software download, wouldn't they also be able to compromise the hash value so it matches? And yeah, this is true in a way. It's actually a much harder problem to change, that static web page that they're displaying. But the thing with the download is often, especially if you're getting it from mirrors, VirtualBox might not host all of their downloads on the same website. They might have, and we might be able to see this actually on Ubuntu if we go back to there. But they might have mirrors, on hundreds of servers all over the place, and even torrented servers here that are actually seeded by other users. So you can usually trust stuff coming directly from the websites. There's really complicated attacks. Somebody could be running an ARP spoofing attack on you specifically, which would be tricking your computer into thinking that the Lubuntu.me address resolves to something else. But that's probably not going to happen. The most common problem here is those third-party mirrors, if that makes any sense. And I guess at this point, hopefully everyone's got it downloaded, so I'm going to go ahead and start setting it up. So once you've downloaded that exe, you can just run this. I've already got VirtualBox installed, so I'm not going to run too much through the setup, but I think unless you like, your software installed in specific ways, you can just hit next through and use the default settings. Usually I'll leave the register file associations and get rid of this stuff, but again, that's up to you. And go through that setup. It should only take a few seconds. And yeah, you'll need to give administrator privileges for it to install its stuff. But once that's done, you'll get something that looks like this. Without these 5 things. These are my virtual machines that I already have set up. I have Kali Linux and MX Linux and a few Windows virtual machines. Again, you can run any sort of computer you can imagine inside of your computer. There's a caveat there, but essentially, any sort of operating system you can get. So I've got all sorts of Windows for different malware analysis stuff, and Kali is the big penetration testing operating system that comes with a bunch of cool tools. But once everybody's here, we can just go ahead and hit new. Actually, it's right on the front there. You don't even have to navigate into a submenu. If you hit new here, right, we're going to create a new virtual machine. Going to make this nice and big. And we're going to call it, whatever you want. I'm going to call it Ubuntu. That's all caps. Ubuntu, because that makes sense to me. The machine folder, the default should be fine. I've left it as the default on my system. If you want, if you have a specific, separate hard drive you use, or some other path you use for, a lot of work, or you want to install all these virtual machines in a specific place, you can change the machine folder. But, the default is fine. It goes to your user directory. So this works for me. And here is right below the machine folder. We can select the type of machine. We actually, so we should select Linux here. We don't have to do too much customization. And in Ubuntu 64-bit, so it looks like we can just go with the setting we were given. And we can decide how much memory we want to give this machine. So depending on your machine that you're using, you can make your own decision about this. Usually it's good to have at least 2 gigabytes of memory. So I'd put no less than 2048 megabytes. I think most laptops these days come with 8 or 16 gigabytes out of the box. So this shouldn't be too much of a concern. You can also usually drag it up the green all the way up to that red area. VirtualBox will kind of guess as to what your system can handle. reserves some in this red for what your operating system needs to use, and it'll tell you, in the green is often what's safe enough to give this machine. Because essentially what you're going to be doing is your hardware is going to directly be interfaced by this new virtual machine. Just like when you're running Windows on this hardware, it's interacting with your processor. It's interacting directly with your GPU, with drivers and such. But the way that the virtual machines work is very similar. It's almost as if you're just running you're running your own operating system. So when you give it this much memory, if you give it all of your memory, this will conflict with your host, your main operating system. If we give it all the memory and we end up doing a lot of stuff in this virtual environment, Windows on the outside will kind of start breaking down. So usually you want to stick away from the red, but give it as much as you feel comfortable with, and call it that. So now for the hard disk part, you can just create a virtual hard disk now. If you're importing old virtual machines that have saved stuff, is where you play around with this, but for us, we don't need to bother with that. And this menu will pop up for creating the hard disk. I like to give 20 gigabytes. You can actually give any arbitrarily sized amount because they're dynamically allocated. So when I select 20 gigabytes for this hard drive and I say it's dynamically allocated, it won't instantly make a 20 gigabyte large file. It'll, as the machine runs and as it requires more, as you save more stuff inside this virtual machine, it'll expand that virtual drive file. So 20 gigabytes is usually safe, especially with Ubuntu. That's probably enough. If you want to give it more, you can. I'm going to give it 50 gigabytes because why not? But again, if you're leaving it dynamically allocated, even if you only have a terabyte of memory on your machine, you can probably do this. I'm not sure, there actually might be limits. VirtualBox might not let you do that, but technically you could probably get away with it. So yeah, let's give it 50 gigabytes and say that is that. And you can the default name is going to be the name of the virtual machine. That's fine. You don't need to play with this. Here, there's a few different file formats for hard drives. There's the VHD and VMDK are kind of used. They're more accessible formats. So, if you want to move to VMware, that other virtualization software I mentioned, these two are more easily compatible. VDI is VirtualBox's proprietary disk image format, and it works the best with VirtualBox, so we're going to leave it with that. So that should be fine. And that's sort of most of the setup that we have to do. We're going to tweak some more settings, and then we're going to actually run the install once we boot this up. But hopefully everybody is at this point with me. Can I get a confirmation? Maybe somebody in the chat say that they're following along. Am I moving too quickly? Is this going well? We have to balance sort of going slow so everybody can set up and work along with me, but also with the stream or the recording. All right. Okay. So if somebody says that they're okay, but we have to balance with the recording so that those people who are watching later don't get painfully bored. So now that we're here, we can actually open up settings again, and we can get a more verbose setting menu. So if you go to the System tab, you'll see again the memory will pop up that we already set up. Here you can change this. In fact, at any point while you run this system, you can, when it's shut off, but between boots, you can alter the system memory. So it doesn't really matter, that initial setup that much. Yeah, everything can sort of be changed. Take that with a grain of salt, because sometimes this can cause problems. Say if we want to just swap out hard drives, that can sometimes can break things if you're not careful. But for the most part, these things can be changed dynamically. So I'm going to go back. I'm going to give it 4 gigabytes, just because it doesn't really matter. That stuff is all fine. Another important thing is if you have a processor with a lot of cores, it might be worth giving your virtual machine some more processors. This will just allow it to just the same, like I said, your operating system, your primary operating system interfaces directly with your hardware. So will this. So this is literally allowing your virtual machine to access more of those CPU registers and cores and so The execution cap is also fine. If you're worried about slowing down your host machine too much to the point where it can break, you might want to turn this down a little bit. I leave it at 100. That's just me. But if you want to make sure there's a little, it'll kind of choke off your virtual machine if it gets too intense for your host to manage. So if you have a weaker laptop, you can play around with that. You don't really need to enable these. We don't actually have, well, I'm not going to get into what those mean because they're irrelevant for right now. For the display, here, you can give it more graphics memory if you'd like. It's not, yeah, that was loud bass, right? I don't know what that exactly was. I don't think that was feedback. But okay, we'll ignore that. All right, so we can give it more video memory. We're actually not going to be using too much. Okay, that makes sense. I thought it was the Discord chat. It seemed like it. We're not going to be using too much video memory. We're going to be doing a lot of work in the terminal. But to make your experience smoother, you can give it as much video memory as you can. The monitor stuff doesn't really matter. Now for storage, this part's important. It will actually be prompted when we hit run to add this, but just to show you how you would normally add more storage devices, we can do it in here. There's two options here. There's one to add disks and one to add hard drives, right? I should say optical drive and hard disks. So if we wanted to add, we've given this 50 gigabytes. If we want to add another hard drive of 50 gigabytes, we can go ahead and add a new, SATA controller and go ahead and also add, well, actually I already have it. So I can, we can just add a new hard drive if we want. But what we want to do is actually add an optical drive and connect our Lubuntu disk image. Just like the file we downloaded is an ISO, you might have noticed, for Lubuntu. So this is something you'd burn onto a disk and shove into your CD drive and boot up with, right? We're going to do the same process, but virtually. So we're going to pretend to shove this into our virtual, or to pretend to shove it into our hard disk drive, or not floppy drive, disk drive. This is old technology, right? Or optical drive, but only do it inside the computer. So select your disk image file you've downloaded, and that should pop up now here. You won't have this other stuff, the guest editions and the Kali and the MX won't appear for you. That's my personal files that I already have added. But you should now have, in not attached, Lubuntu 20.04. So that is good. You're going to hit choose with that selected, and you should get, under that IDE controller, your Lubuntu disk image. And at this point, you can go ahead and just hit OK. This should be set up. And I'm actually going to, so again, the important thing to do here is to go into storage and add that disk. And just to demonstrate, in case you don't do that, if you want to be a rebel, if you just hit start without a disk, for the first time we'll be asked to add a disk. So no bootable medium will be found, and actually since I manually added it and then removed it, it might not prompt me. Yeah, it's funny. But normally a message would pop up saying no bootable medium found, would you like to add one? But now from here you can, if you already have it installed, you'll be at a Lubuntu install page, but also while it's running we can insert optical drives. So if we go to devices, optical drives, and click on that disk that we already added, we can just insert that and we can just reboot, and this should work fine. Oop, not preferences. So now we've plugged in our disk and we're at our Lubuntu install page. Select select your language, please. And we can do start Lubuntu. We can ignore everything else, just start it. So this will do a live boot, I think, and then from the inside we can install. Yeah, okay. Yeah, we'll see exactly what happens. I haven't, done a dry run of this. I'm kind of doing this as I go. without any preparation. So what we should get is a live install. It'll bring us, and it'll look as if we're in an operating system, and we'll have to install from inside of it. So yeah, it looks like that is the case. So once you're in here, you're going to just click on this install Ubuntu and walk through this. So select your location. This should all be detected and fine. So for the partitions, we're going to just use the default setting. Sometimes there are reasons to, especially if you have multiple hard disks, to be more particular about partitioning your drives. But erasing the entire disk and formatting it is more than enough, more than good enough for virtual environments. So just hit erase disk, and then hit next. And we can do our name stuff. So let's do my alias, and we'll call this the name of the computer. You can call it whatever. I'm going to call it Mu. That's funny. And a password. This is an important part. You don't need to use your exact password, but you should use a password. There are some security risks. Even though this is a virtual environment, there are some fairly sophisticated ways that they can actually compromise your host machine through this. I don't need to get into exactly that, but it is best practice to use passwords. Log in automatically if you want. I'm not going to do it. This is a convenience thing. It's up to you. This will summarize the changes we've made. So it looks good to me, and we can just install now. And this shouldn't take too long. So, how's everyone doing? Is everything going all right? Any points of confusion? Cool. Yeah, so this will go exactly as fast as your computer can manage, right? So I'm on a desktop that's got a lot of resources, but if anyone of you is on a laptop, this might take a little bit longer. Hopefully not too much longer than us, but I'll try to wait a little bit after this finishes. Looks like we're getting some ads. I guess I'm thinking, meantime, if there's anything productive we can do. Oh yes, I'll introduce the next task we'll be doing. So on over the wire war games bandit. Okay, so this is a sequence of challenges. Right on the left, you will see there's a bunch of levels. But there are a bunch of challenges to introduce basic Linux commands and tools and other stuff to get people acquainted with Linux so that they can move on to more advanced security and sysadmin and other sorts of Linux stuff. So I think that this is kind of what I said, that it's for beginners and stuff, but we're going to start at level 0. And it's going to start with us. We're going to have to remotely connect to their servers, and it's going to progress. We'll do all sorts of things. It's been a minute since I've done these, but if I remember correctly, it's all pretty much just learning the basic tools and tricks. So this will be real fun stuff. Checking back on our install. We are getting somewhere. This is actually taking longer than I expected. I thought it was going to be a gigabyte is the first part. And I thought the install would be almost instant, but I guess we're just going to have to slow down a little bit. All right, 93%. So I actually have a question for you all. Are people using laptops, desktops? Do you guys have multiple monitors? One of the concerns I had was that people weren't going to be able to watch and do at the same time. Like maybe you can do like a halved window on one screen or something. But how are you guys doing that? Is this working well? I guess we'll just assume it's going well. No one's complained so far, and it seems people are following along. So I've at least finished. Once you guys finish as well, you can just restart now. That should be fine. We want to get out of that live install, or not live install, the live boot of Lubuntu and go into our version of Lubuntu that's been installed on the hard disk. We could just continue using the live for all of this, but our progress will be gone once we finish, and we won't really have much hard disk space to work with. It'll be whatever VirtualBox decided to give to that CD drive, however much space or size it decided to give the CD drive. I don't know what it is by default, but okay. So now it's saying please remove the installation medium, then press enter. This is I didn't realize that we'd have to do this. Yeah, so we're gonna have to disconnect that drive. So if we go back to optical drives, it looks like it's already been removed actually. So it might remove it automatically for you. Just hit enter and see if that works. Oh, yeah, it worked. Okay. All right, this is Lubuntu. So this is going to ask us to upgrade and update all of our software. I'm going to actually ignore this. You should all do this. It won't take that long. I might as well. You don't need to do this yourself right away. If you want to follow along, this shouldn't be too important, but you should always, in general, make sure to keep your stuff up to date, right? Especially for security. I'm just concerned more about time, but I guess if people are still catching up to me, then this will be fine. It won't take too long. And also, I guess I'm going to adjust my display. System tools, maybe? Graphics. Desktop preferences. Guess there's no good way for me to adjust my my resolution here. Well, I mean, there has to be. I just gotta figure it out. Screensavers might be it. No. Yeah, so I mean, I don't usually use Lubuntu or even Ubuntu actually. So forgive me now. I just want to make this a little bit bigger for all of you. I figured that there'd be an easier way to do this. I don't know. There we go. And let's go 12, 19. 20. All right, beautiful. And let's switch here. And how does that look? Awesome. No. Okay. So our full upgrade is still running, but meantime we can actually maybe get a little bit of stuff going. Oh, that's actually a little frustrating. The resolution's a little bit too high. Just a little bit too high. By a razor thin margin. Oh well, I guess I can see a little bit more than you guys, but that's fine. I'll just make sure to drag stuff up. So meantime, we can get Firefox open and open up War Games. You guys should do the same thing. Again, just you can Google over the wire bandit. And go to level 0. So the goal of this level is, actually, let me do this. The goal of this level is for you to log into the game using SSH. The host to which you need to connect is bandits.labs.overthewire.org on port 2220. The username is bandit0, and the password is bandit0. So we've already gotten our first credentials. This whole game, war game, revolves around getting user credentials. So if we make a notes file just to record these, so if we lose one of them, we can go back without having to redo progress. For each level, we'll get the next level's username and password, right? So the first one's bandit0, and the password is bandit0. The next level will be bandit1, and there'll be some password, and the next one after that will be bandit2, and there'll be some password, and all the way down. I think there's like 20-something levels. I'm not too sure. We'll get through however many we get through in the next hour or so. But again, after we finish here tonight, I encourage everybody to continue along at home and get through these, because they're really cool challenges, especially the later ones. Some of them are kind of neat. Once you get past kind of the introductory learning stuff, it starts getting tricky. So this first task is to use SSH to connect. SSH is called Secure Shell, but it's a protocol for remotely connecting to a computer, opening a shell connection on another computer. So you've probably heard of this before, maybe from some hacker movie, or just maybe you've used Amazon Web Services or something. But SSH is a very, very popular tool. So if we go to actually, Control-T should open a terminal on most Linux. That's annoying. It doesn't do it in here. I really like that bind. Again, with Linux, you can kind of customize everything. So, in fact, you could change it so that hitting Control-T opens up a terminal. But it looks like we're going to have to, at least for now, open it up ourselves. So QTerminal is the terminal that we're given. And we should get something that looks like this. And I can't do that. I'm going to have to make this bigger. Appearance, right? This is where it should be. Why can I not make this bigger? View. That's got to be it, right? No? How do I... Oh. Zoom in. Control plus plus. Oh, it's plus. Wait, I was doing that. Maybe I just didn't see. Maybe it totally hit that size. It's just such a marginal difference. All right, so let's go to... Yeah, that should be big enough, right? Does that look good? In fact, maybe a little bit bigger. Yeah, so that's a really good question. So Coolslaw asks, why are we using a virtual machine to SSH into the server and not our host machine? So actually, you could, right? You can do any of these challenges on any operating system. It'll just be more difficult. So to SSH on Windows, you actually have to use a tool called, I think PuTTY is the most popular, but you have to use some tool to do this. In Linux, a lot of these things come built in. And a lot of the things that we'll be doing are very easy to do in Linux, whereas they would take a great amount of effort to do in say Windows or Mac. I guess a little bit easier on Mac, again because it's a Unix-like operating system. But this is just very good for being able to do so much out of the box. You get a lot of power in Linux because if we on Windows, say if we switch back to Windows, if we wanted to make a file, right, and call it like, I don't know, let's make a file and call it test, right? So we have to make a new text document. You got to right click in new text document, call it test, and hit enter, right? And whatever, it didn't take too long. But if we go back to Linux, we can just do that, and that did the whole thing, right? So what touch does is it just creates a file. And this isn't too important of a demonstration, but the idea here is that with typing commands and learning to use commands in Linux, you can do a lot of things very quickly, efficiently, and neatly, right? So you're right in saying that yes, we could just SSH from our own host, but it's easier and a better practice to use Linux, especially for UMass CTF, which we're now preparing for, right? A lot of the challenges will expect people to have Linux set up, so we'll design these challenges around you guys having Linux set up, and we'll have tools in mind that we use to solve them, and we hope that you guys find the same paths using similar tools inside Linux. We could very well design a bunch of CTF challenges to be done in, say, Windows or Mac, but it's just easier to have everybody do it in Linux. So at this point, I hope everybody is to where I am. I was trying to maybe pass some time there. Yeah, you're welcome. Kind of trying to pass some time there by over-explaining that answer to that question. But at this point, we should all be in this terminal, right? So in this, instead of having to install PuTTY or anything, we can just use SSH. That's simply it, right? So there's a few things here. So in SSH, in fact, in anything, actually, I'm going to step back for a second. Let's get acquainted with Linux first, because I don't want to jump too far ahead and assume any sort of knowledge at all. So the most basic command in Linux might be cd. It stands for change directory, but if we cd to this slash, this will take us to the home directory. That slash stands for, not the home directory, sorry, the root directory. That slash just stands for the root of the file system. So the way Linux describes the file system hierarchy, file hierarchy system, I think, FHS, but they pretty much outline a way that file systems should work in Linux. So when you look at your file system, you'll see a number of things. In fact, that's actually not too nice. Okay, so we've just using the typing ls, we've listed out the contents of this directory. That would be the same thing as in say in Windows. If we want to look at my downloads, right? I can type in dir, and that'll just list out the contents of this directory. Same thing in Linux. We can just ls, and this will list out the contents of the current working directory. Okay, so we see a number of things. That should be very confusing to you. I hope you're all very confused. But we can work through this kind of one at a time. I guess we can just go alphabetically. The first thing we see is this folder called bin. So this is the folder located at just /bin. This stands for binaries. Inside this folder, there'll be all sorts of software, right? So binary applications, compiled applications that can just run, right, are stored here. So if we actually look in, if we change directory to /bin, we can list out the contents, and we see all sorts of words here, right? But in fact, we'll see a lot of things that might sound familiar. So like if we go to the top here, CP, here's something that we'll find out later that what this does is copies files. CMP, this compares things. Everything you type into this terminal is essentially here, right? All these things we're just running small little applications as we work. So like if we want to choose one of these, maybe just like a mixer, right? I type in a mixer, and it looks like that this is a mixer. This is the output it gives us. I don't really know what a mixer does. It seems to be some sort of audio mixer tool. But yeah, so anything in bin is pretty much just a small little application that we can run. The next thing after bin, we have dev. Dev stands for devices. This is where you'll find stuff like your hard drives and like floppy disks and stuff like this. Nothing too like USB stuff. Nothing too important for what we're doing here today, though. Next we have home. This is more important for each user on a Linux system. You'll have a home directory, and this is, you could think of, it's analogous to in Windows. If we go back to Windows, if we go to my operating system, we go to me. This is my username, and here we have all my stuff, right? You've got my desktop, my documents, my downloads, and stuff like this. Same thing in Linux. You have cd home. You have your users, right? So let's go into my home, and you see my desktop, my documents, my downloads, music, stuff like this. And this is the file I touched earlier. So actually, just to keep it clean, let's remove this. RM stands for remove. I just did some magic there. But yeah. So there's some basic things in the terminal that you'll kind of learn to use as muscle memory. But most things also, if you're ever confused about anything I've typed, you can type in man, which stands for manual, any tool. So what this will do is bring up the man pages, the manuals for any given tool. So we see that RM removes files or directories, and there's a more verbose description here and options that we can give it. So we can, if there's a non-existent file that otherwise would give us an error, so if we try to RM test, now we've already removed it, it'll say that it can't remove it. But if we force that, then it'll just do it anyway and won't complain about anything. These things get useful as you do more complicated things, but it's not too important for right now. So with any Linux program, there'll be a number of these options. The convention is to use dashes. Sometimes it's double dashes when there's words following it, but this is convention. You don't really find it extremely standard. They kind of change. There are you'll get used to using different flags, and as we work through tonight with some certain tools, we'll have to do this a lot, resort to man pages to kind of learn as we go how to use these tools, because you're not expected to remember everything, right? You're not expected to know all of these tools and answers. But a very cool thing about Linux is it's very well documented. We can find out everything that happens just by looking at it, looking at man pages and reading documentation and such. So to continue with the file system, if we change directory back to the root, we can list this out, and we got past bin, which is all those binary files, our devices, home. Now we have lib32, libx. This changes between distributions. Sometimes it's just lib. Sometimes there's multiple libs to distinguish between the types. But these are library files. So those bins that I mentioned earlier, those binary files often require libraries to help them. This is the same thing if you've used Java. I think, in Java, most people have done this in high school at least. But you'll import libraries, right? Like that standard IO, or actually it's been a long time since I used Java. I'm not sure what the most important one is that you use in all your Hello World programs, but it's probably I'm not sure what it's called. I was standard IO is the C library for the same stuff, but there are libraries that you've used before. These are the same things. They're files to help those binaries run. After these libs, we see media. Media and mount are very similar. They're both places to mount devices. So if you have a hard drive, they'll be mounted in media by your operating system pretty much automatically. So if we go into media, we can see case sensitivity. This is a little lesson here. Things in Linux are case sensitive, so capital LS doesn't work, but lowercase ls will. So actually, media, there's nothing mounted in this here. Different operating systems will treat this differently. Sometimes it's the case that you manually mount devices into MNT, and media is where they're kind of managed for you. It looks like maybe they use the opposite, or mount is just where they put everything here. Okay, yeah. So it looks like I just don't have any devices right now, but yeah, that's fine. Okay, so moving on, we have opt. This is optional space. This is where software you're installing by yourself, maybe some extra files you can put here. So by default, it should be empty. Yeah, but here is where if there's some big software you found on the internet you want to install, you wouldn't put it directly in bin. You might install it in opt if it's not managed by the package manager. which I guess I can get to. I'm trying not to throw around too many terms. So after OPT, we see root. This is similar to home, but it's for the root directory or for the root user. You can think of root as analogous to an admin in Windows or Mac. It's just the user with the most privileges on the machine. So not much to see here, but yeah. sbin is very similar to bin. These are just binary files that are sort of, so you can think of them as system binaries. They're sort of binaries that need special permissions to run. So this would be like in Windows, if you wanted to use your registry editor, you would need to have administrator privileges to edit your registry. Same thing with sbin. You'll usually need to have administrator privileges to run stuff in here. srv is for it stands for like server. Here is like if you have like an FTP server, which I don't really need to explain what these things are just right now. But if you have some sort of network server that you're hosting, files for it would go in here. TMP is kind of just temporary space. You can think of it. I think there is actually a TEMP in Windows, but yeah, there's all sorts of temporary storage is used in pretty much every operating system, right? So you're familiar with the idea of that. So if you can use things in here, you can touch things in here, but over time they get cleaned up by the operating system. Var is for variable. It stands for variable. It's kind of variably sized software, you can think of it as. So if you have a database that you expect to grow in time, you would put it in var. If you have a web server, often these things that kind of need more space as they go. This is just convention again. There's no good reason why we have to put all these things into one folder. It's just to keep things organized. Boot is just where your boot files go. So inside boot, you'll see like there's actually the I keep hitting caps lock. I have a new keyboard. There's actually, these are all the boot files that we need. Like grub is a first stage bootloader you might be familiar with or maybe have heard about. But yeah, so that's a good point. So Tariq mentions that var can also hold log files, right? So like these files that'll collect data over time will go in here. Yeah. So yeah, boot's just for your boot stuff. It was kind of a recursive definition, but I hope it makes sense. Etc. Actually stands for etc. This is a hotly debated topic, right? But the co-founder or the co-creator of Linux confirmed that it actually stands for etc. But here, these are where configuration files will go for system-wide things. So information about all your network devices, information about your users will go here. So there's actually two really cool files that I can talk about in etc. So if we use this tool called cat, which I guess I'm gonna man page this first. But there's this cool tool called cat that'll concatenate files and print them to the standard output. So essentially with cat, you can give it any file, along with some options that we can ignore for now. But you can give it any file and it'll print it right back out to the console. So if I want to print out a file, so it's like say we touch. Well, I'll show you here. So if we want to cat out a file in etc, we can just type in cat and then put the path to that file. So etc password is one file that holds user information. So if I cat this out, a whole bunch of stuff is going to come out. And you'll see that actually each of these is a username. A lot of them are kind of system managed usernames that we can ignore, like the daemon and sys and stuff like this. But here root is that super user I mentioned earlier, that administrator, and we'll be in here somewhere. Yep. So here we are. Yep. And it has some information about us, and it tells us where our home is, where we live, and also what terminal to use by default. So we use bin bash, right? So when we log in, we see just like we're in now. This is the born again shell. It's the shell that we're using right now. So that's what goes in etc system-wide configurations. We already covered lib, lost and found. This isn't in the FHS standard, but it's like similar to a recycling bin. Not too important. MNC already covered. Proc will cover because that's important. So everything in Linux is a file you can think of. So when we make a text file that says "hello world," if we touch hello, and if we so we're in the root, so we're going to need special permissions to do this. But if we cd to our home directory, to do this neatly, we can use this tilde. That'll just take us to our home. But if we touch hello, and we echo hello world into this is a redirect. I'll get more into this later. This is just for demonstration. But if we echo that into hello and we cat out hello, we see the contents of this file is hello world. So text files are just a file in Linux. But at the same time that text files are a file, so is your CPU. So are each of your floppy disk drives. Everything is itself a file. So those software packages I mentioned earlier, how on Windows you'd have exes, where it's sort of a file there. Same thing here. Binaries, they're just files. And if we go into proc, we'll see that this has information in the form of files about every single process that's running on our system. So if we go back into Windows, here, if we go back into Windows and you open up a Task Manager, or on Mac I forget what it's called, but you have the same thing essentially. But you can see there's all sorts of processes, right? And in fact, each of these also has some properties and some a process number. I'm actually not too sure how to get that process number easily. Go to details maybe. Oh yeah. So here are the process IDs. So each of these processes has a number and there's some information about it. Same thing in Linux. We have a number of processes and we can see them here by their number, and it'll contain, these are actually folders, but each of these will contain files containing information about running processes. So if we open up HTOP, which is a tool to just inspect the running processes, just like Task Manager, there's all sorts of stuff. So there's the PIDs, 990. If we quit out of that, this folder 990, wherever it is, I'm not going to find it very easily. But each running process will have some files in proc associated with it. So you don't need to really touch proc too much, but it's cool to know that everything is running in there. Same thing with run and snap. We don't really need to get into. Snap is actually mostly a Ubuntu thing. It's for a special type of software package. Same thing. Well, so and sys2, more configuration stuff. User, same thing. So there's user. There's in user. There's non-essential stuff. It's kind of for applications. So that's what the file system is, more or less. That was kind of quick. Hopefully maybe you want to review that later. You can rewatch the video. But it's good to kind of have a way to feel around the system. And now that we kind of know where we are in the world, we can move around. So we can cd to home, right? And then go to your username, and now we're in our home. And if we want to go to our desktop, say, we can go here, and in the background you'll see the desktop. If we touch hello ! That file just appeared here. And we can remove that, right, because we already learned rm, and just remove that same file. You'll notice here there's this actually backslash before the exclamation mark. This is for escaping characters. So there's some special characters that aren't quite allowed to just be typed. And to escape those things, there's you have to put backslashes in front of them. So if we had a file that had a space in the name, you'd have to do something like that, where the space is escaped by the slash. I should also say a very useful thing to know is that hitting the tab key will autocomplete. So depending on what you have typed, if there's a match, if the only remaining file in that directory contains that prefix that you've already typed, it'll automatically complete to it. I can actually, it's not as straightforward as you might imagine. If we like create touch hello1 and touch hello2, we have 2 files and we want to remove one of them. We can tap complete again, but it won't fill all the way to the 1 or the 2. It'll only go up to the point where there's that ambiguity between the two things. So you'll have to fill it in for yourself. So we can remove both of these. If you hit the up arrow key, it'll bring you to the previous command. If you hit the up arrow key again, it'll go to another previous command, and so on and so forth. So we can remove that one too. And now we're kind of acquainted with our files. So we're in our desktop. Okay, that's fine. We can work from here. Actually, I'm going to go. Yeah, let's go to documents. Yeah, let's work from documents. So with CD, there's also some shortcuts. So if we wanted to just get to our home, the tilde is just a symbol that means the current user's home directory. Similarly, if we wanted to go to the root directory, you can just type in that slash. If you want to represent the current directory, it's a dot. And if you want to represent the directory that's one higher than the one you're in, because you can think of a file system as a tree. If you want to go up one level, so if we want to go from desktop back to the root of our home, we can just type in cd ... and this will bring us back to this area. So now you're here, we can go into documents, and this is empty, so let's just work from here. This is a neat little place to work. So back to over the wire. We have to SSH into bandits.labs.overthewire.org on port 2220. Okay, so I've copied this host string here, just so we don't have to retype it, although you could. And we have to remember this. So this is port 2220. So by default, SSH uses port 22. So if we just typed in SSH with this, I did not copy this. If we just type in SSH with this address, it'll try, but it'll fail because that port won't be open. We actually have to specify the port we're using. So if we, again, open up the man pages for SSH, we'll see that the -p option will allow us to put in a port. So we can SSH -p, and that port we wanted to use was this. And now that we've made this connection, it'll have us verify its public key. And we can just hit yes. And now we're prompted for a password. So actually here what we're trying to do is, I sort of made a mistake. So what we've tried to do is log in as my username into bandits.overthewire.org. So we actually don't want to be mu at this address. We want to be bandit0 at bandit.labs.overthewire.org. So we can Control-C to close out of that. There's an important thing. So hitting Control plus C at the same time will cancel the current executing program. So now if we try to do this again, we can specify that username. So we can do bandit0 at bandit.labs.overthewire.org. And this will do the same thing. We've already verified the key, so we don't have to do that again. But now we're being prompted for bandit0 at this address's password. And we know that password is bandit0. And boom, we're in. So the way that the war games here work is for each, like I said, for each level we need to get a file that contains the password for the next level. So if we list out the home directory that we were plopped down into of bandit0, we see that there's this readme. If we run file on readme, file is just a tool that tells you information about the file you mentioned. We see that's ASCII text. So since it's ASCII, we can cat it out. We can just cat out readme, and we see that this long string is in fact our password for the next level. So we can copy this selection, and for bandit1, that's going to be their password. If we go back to our website for level 1 to level 2, I'm going to bring this to the center, make it a little bit bigger, because I can't even see that. The password for the next level is stored in a file called dash, located in the home directory. So now we need to SSH into the next user. So from this connection, I think we can actually just change without so there's two ways we could do this. We could leave and then re-SSH in, but I believe we can just actually change our user using the SU tool to bandit1, and we'll be prompted for the password, and we already have it in our keyboard, so we can Control Shift wait. Yeah. So we can paste that. Wait, why don't I have that in my keyboard? Okay, that's weird. So sudo bandit and type in the password. Huh. So I guess maybe we do have to SSH in. Did I spell it wrong? No. Yeah, okay, I guess let's just SSH. So we can just type exit to exit out of this SSH connection, and we can do the same thing, but now just change the 0 to a 1. And now we can type in their password. Did I skip? Oh no, okay, I don't know what was going on there, but yeah, so just pasting that password should work just fine. And now we're in as bandit1. So now, as I mentioned, there's a file called dash in our home directory, and we need the contents of this. So again, we can just cat this out, and we see that nothing really works. And this is because the dash is actually a special character, like I was mentioning before. So we have to escape this, right? So if you cat with that. I don't know why this isn't returning. Oh, did I? Oh, no, I didn't. Okay, so since the slash represents the current directory in bash, what we're going to have to do is go back a level, and then I think we can do this. Yeah, you could remove it, rename it. So now we want bandit1 / dash, right? So what I did here was I went back a directory and then I printed it out. So somebody in the chat asked if you could just rename the file. So for these problems, there's a number of ways to actually solve them. So let's see if that works. So we already have our password, but let's see if we can just rename the file. So if we go back into, actually we can just rename it. So if we do mv, this stands for move, but what we're going to do is move this file into a new file name. So it's not like in Windows you could imagine renaming where you right click and rename it. What we're actually going to do is like, it's kind of like cutting and pasting something, but in a different location with a different name. So we can mv the / bandit1 / dash, and we can call it, let's call it bandit1 pass, right? Oh, so we don't have write directories in this or write permissions in this directory, so we actually can't move this. But normally if we did have access to write to that directory, we would have been able to do that. So this is an interesting point that I should go over. In a Linux file system, there's all sorts of permissions. So if we ls-la, we can -ls, we can list out some information. Yeah, so the reason it didn't work without it is because the dash, the reason why we couldn't just cat out dash is because the dash is a reserved special character, so we had to escape it. So we just went back and used the ./bandit1 dash. So if we ls-ls, what we do is list out some information about the directory we're currently in. So we see that in this directory there's only one file. It is this hyphen file. It was created, at this date or this time, and there's some information about the file. So right here is kind of what we care about. So we see, starting from the front, this is kind of a hard example just because there's not many other files to compare it to. But if we go to so what I've done here is I've opened up a new terminal window. So if we go to our desktop, and ls-ls, there's a number of different things we can see. So for each of these files, so for notes, this file that we created to hold the passwords, the owner of the file has read and write permissions, but they don't have execution privileges. The people in the group of that user have read-write privileges, but they don't have execution privileges. And everyone else only has read privileges. They cannot write or execute to this file. So normally, if you could, execute this notes, you would see an X in where these dashes are. And if this was a directory, not just a normal file, there would be a D here at the front. There's also the file size, which is here. This hasn't been saved yet, so it was 0, but if we refresh this, it's now 118 bytes. Yeah, so Tariq asks why we didn't use the slash before the dash. So the reason is the dash is that option. So even if we do escape the dash, it's expecting that option next. So we just went back a directory and put it so that the whole request, instead of having cat and then a separate thing, we were catting one string of that whole. I'll show you what I mean. So here we have this string. We're catting out the file in this location instead of starting that location with the dash, which would expect an option after this. We haven't already told. It doesn't already seem like to cat that this is a file path. It looks like to cat that this is expecting an option next. So by doing this, where were we? A few behind. Well, I don't know where it went, but by putting the whole path, we allow it to realize that this is actually a path of a file. So now we have the next password, and we can continue on to the next level. So I'm going to copy this so it's in my clipboard, because I think I've put something else in there since then. And we can exit out again, and we can hit the up arrow to bring us right back here, and type in bandit2. Type in the password by pasting it. Oh, I think I pasted it twice on accident. Yeah. So now we're in as bandit2. If we list out a directory. Okay, so actually we got ahead of ourselves. We can go to the next page here so they explain what's going on. But the password in the next level is stored in a file called spaces, located in the home directory. So we found this file. It's just called spaces in this file name. So this is very similar to the last one. We're going to actually more explicitly escape these characters. So now there's no hyphen. There's no reserved characters that these binaries are expecting. It's just the spaces. So normally, if we were to cat out spaces in this, spaces in this file name, what cat would expect is, it's spaces. What cat would expect is to print out a file called spaces, and then print out a file called in, and then a file called this, and then a file called file name. But we actually don't want to print out 4 different files, all named one of those substrings. We want to print out one file named spaces in this file name. So for each of the spaces, we can just escape it, and this should work just fine. So that's similar to the last one. I don't think anyone should have any problems with that. We can copy this selection and put it right here. And again, rinse and repeat. We're going to exit and go back. Yeah, you can do it with quotes too. There's again, so for each of these puzzles, there's so many ways that you can solve each of them. And once you start learning the tools, like the basics, especially for some of the later ones after the stream concludes, there's cool ways for you to figure them out to do yourself. So you can find walkthroughs for each of these levels on the internet, but you might find your own way that works well. And that is what's so cool about hacking. So now we can SSH as the next user and put in our password. And we're in. And we should resort back to our explanation. We see the password for the next level is stored in the hidden file in the in here directory. So kind of going back to the Linux file system, there's a convention to express hidden files, and that's just by putting a period in front of the name. So if we list out this directory, if we go into in here and we list out this directory, we'll see there's nothing. But if we man ls, you'll see that there's an option -a that will not ignore entries starting with period. So the way that hidden file convention is enforced is tools will like ls will ignore by default those files. This is kind of to make it pretty. So if like I want to list out the root with -a, there's nothing really in root, but like maybe in Etsy there'll be some good hidden files. Not really. Maybe boot. But sometimes there's a lot of hidden files that humans don't really need to use that you can kind of ignore. There's no good examples I can think of. Putting those periods in front of them and having this ls tool ignore them is just more convenient for moving around with this terminal. So you don't have to look at 100,000 entries when most of those are just like temporary hidden files that you should never have to worry about. So again, with that -a flag, we won't ignore files that start with periods. And we see that there is a file called .hidden. We can just cat out .hidden. Period's not reserved, so that won't have any problems. We don't have to escape that. And we've already got our next password. So we're chugging right along now. In fact, we're chugging along so quickly we need to add more usernames. I'm just going to do a bunch now. Did I do 6 again? Yeah. Maybe this will be good for now. This is in the clipboard, and we can exit and SSH again. In fact, I'm gonna look back here first. So the password for the next level is stored in the only human readable file in the in here directory. So if we SSH as bandit4 and we put in our password, we're in. And if we cd into the in here directory, we'll see there's a bunch of different files, all of them actually starting with this dash. So what do they mean by human readable? The way in Linux, most of these files are going to be like those that bin directory, like I mentioned. A lot of these files are binary. So if we try to cat a file in bin, so like bin. Let's do bin bash, right? This is the terminal we're using. If we try to cat out the contents of this, we're like, whoa, it's a bunch of junk, because this is code essentially that's compiled that isn't meant to just be read or anything. This is junk in a sense. And actually, we can see explicitly what type of file this is if we run that file tool on it. So if we type in file bin bash, we see that this is an ELF executable that's compiled x86 code and some other information about it. And if we had a file new tab and make this big, touch hello, and let's echo hello into hello. So now we've added hello touch hello into hello. So there's a bunch of text in here that humans can obviously read. If we run file on this, we'll see it's ASCII text. So what they mean here by the only file that's human readable, they want an ASCII text file. So we can actually use file against all the files in this directory with the star. So let's actually escape again. So we just had to escape the beginning because, again, that option thing was happening. So we escaped the beginning, started with file, and actually I should just be more explicit. So what I did with this wildcard, this means if you've ever heard of what a regular expression is, this is essentially a character that means any acceptable ASCII character can follow from here, or any string of them. So from here, this will take pretty much from the start of this directory. This will run this file command on every single file that matches the convention -any characters. So it's true that file 000 matches the -any characters. That's how it's formed, right? That string. And it's also true that file 05 is formed in the format of -any characters. If that makes sense. So what I did here was I just ran this file command on every single file in this directory. And we see that we have data, 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 and file 07 is ASCII text. So if we cat out /-file 07, we'll see the password. And if we were to say, do the same thing to file 6, it's just some junk, right? Because those aren't ASCII characters. So we can copy this file and paste it as the next user's password. So to step back and talk a little bit about what ASCII is, for each chunk of data that we call bytes, that is 8 bits, there's 256 different values you can represent, right? 0 through 255. That's 2 to the 8th power is equal to 256, right? So inside that range of 0 to 255, there's some of those values are reserved to mean to computers ASCII characters, and some of them are kind of just used as data. So if you have a file that's a binary, it'll use every single value in that ASCII range as its raw data, right? So a binary file will have all sorts of combinations of zeros and ones, and it'll have all sorts of different bytes. So it doesn't really care if anything's ASCII readable. And in fact, if we again cat out that bin bash, we'll see that there are some ASCII characters we see, even in what seems to be just like code sections that are junk. But these aren't supposed to represent strings. These are kind of just garbage. But if we are typing, hello world, it's represented in the same way, just by zeros and ones in those bytes in the 0 to 256 or 255 range. But there's specific numbers that we allocate for ASCII characters. So I think there's a way to do this in the terminal. Oh, restart required. I don't want to do that. There's a way to print out the ASCII table in the terminal. I'm not sure exactly what that command is, but I'm just going to do it in Firefox real quick. Oops. So if we look at the ASCII table, you'll see that there's, that's kind of small, that like an ASCII, like a hex byte, or a byte that means 0 would be represented by 48.30 hex. If there's like a capital M, right, would be 77.4D hex. So when it comes to the files in this directory, when we cat it out, /-file 00, there are some ASCII characters, but that's sort of just coincidence. That these are a bunch of zeros and ones, and it so happens that these 8 zeros and ones in sequence happen to be that, I got rid of it, but it happened to translate to that 5 in the ASCII standard. So like if we use the tool hexdump, which will just dump out the raw data, that I'll actually probably explain more later. But for now, you can just think of this as printing out the bytes of this file. We see it's sort of random, right? And the that uppercase L is a 4C, but it's not really meant to be an L. on purpose, it's just random. But if we do the same thing for that ASCII file, we see that everything is a perfect ASCII character, and they're all bytes, and it's all beautiful. Yeah, and that this array is the line ending. That means that that's just like if you've ever used in Java that /n, the character turn, it's similar to that, right? This just tells our system that this is a text file and it's ending here. So now that that explanation is done, and hopefully that made sense, we can move on to the next level. So let's exit again, and with this password in hand, we'll SSH right back into the server. And put in the password. Oh, I have to Control Shift V. Did I not get the right one from last time? Oh, am I? Wait a minute. What's going on here? Level 5. Yeah, that should be the right password, right? Yeah, it totally is. I might have copied a space. So let's go back to the previous one. It doesn't look like I copied the right amount of characters, so there's no way, right? Unless this is like off by 1, but I really don't think it is. What is going on? So it must be off by 1, right? So is this the Bandit 4 password then? And I never copied the previous one? Wait, I'm actually a little bit flustered right now. Copy. We know this is the right password. We've used it before, right? And we're just going to paste this selection. It could be like a problem with the server, but I really doubt it. So let's just go back to Bandit 0. We know Bandit 0 is Bandit 0, and that works fine. Yeah, 4 to 5 was that password. Yeah, no, I am shift inserting, right? It's definitely the right pass or right commands. I mean, some of you are probably in this already, right? So we know it's not a server thing. Yeah, I mean, I could just try a new shell, all right? VVV. I could super verbose it and see what happens. So it was Bandit 1. Oh no, it was Bandit 5, right? And the host was. I guess it's up here. -P2220 and super verbose it. And we'll get our password again. So the -VVV flag I put in, normally -V stands for verbose. It means it's going to give us more output of what's going on in the program. With 3 V's, usually it means super verbose. It just puts a ridiculous amount of information. And now, for some reason, that just worked. I did the same thing, but whatever. There must have been some white space character I had copied. I'm not too sure. But let's not savor the moment too much. Let's just move right on. So level 5 to level 6 is the password for the next level is stored in a file somewhere in the in here directory, and it has the following properties. It's human readable, right? So it's ASCII text. It's 133 bytes in size, and it's not executable. So there's ways we know already to tell these three different things independently, right? So we know from using the file tool that if it says ASCII text, then that's human readable, right? So on any of these, if we go to in here, there's a number of subfolders. Okay, so maybe we go to maybe in here 00 and look at these files. There's like a whole bunch of different names for them, but if we run file on spaces, oh yeah, spaces file 2 is fine. This is ASCII text with very long lines, so this actually might not be human readable. We can cut this out just to see. But normally in human readable format, we'd see ASCII text. What the very long lines means is that it didn't find, when file was running, it didn't find those character turns, those new lines in the file. So this is closer to a dump of data than it is an actual readable text chunk. So like if we again run file on spaces file 3, I think was one of them. This is just data, right? So there's all sorts of stuff in this directory and these subdirectories. So we have to sort of automate this, right? Because we can't go manually through all of these. Again, if we want to check the size or if something's executable, we had the ls-ls that we were already doing, and we can list out like maybe in here 00. And we know that if something is not executable, then there won't be these X's here. And if it's 133 bytes in size, it'll tell us here that's 133. So it seems like size is probably the best indicator. So we can use find, and we can look around in the current directories. So dot means the current directory, and that slash will tell us the subdirectories. And let's do dash size, I think is what is size. Actually, we can man find to get the options. It might be dash s or it might be dash size. Dash size n, yeah. So if we man, I never ran it, so it's not in my history. But if we find dot slash size is 1033. This should tell us if there's any files that are that size. So, okay, wait. So I need to get the usage for find real quick because it's been a minute. So it takes options and then starting point and then the expression. Okay. So let's do size, and then let's do dot slash, and it'll be, fine, maybe dash R for recursive. Wait, okay, so dash R isn't a thing. Paths must precede expression. Wait, so it wants a path first. Dash name, dash size. Yeah, so we can do like dash name, so it's nothing. So yeah, I'm actually not quite certain what's going on here. But we can just find in here, and then like we can use like a slash name that can be anything. And let's just like ls. I don't know why the size flag wasn't working. I guess no, this will work, right? Slash size 1033. Oh my gosh, this is so funny. So the reason that none of this was working is because I'm already in the in here directory. So see, my current directory is in here. Okay. So I wanted to be out here. And this should help us better. So it looks like none of them were matching that size, right? 1033. 1033. Size 0. All right, so let's just count out all of them, and we'll pipe this result into ls. So okay, so now we can list the data for each of these files. So after we run in here, we'll get each of the names of the files, and then we'll list out the information about them. And in this, we can just grep through using this tool grep that searches for certain strings in the standard input or in some provided file for matches. So we can use grep to look for 1033, right? And this should contain stuff that says 1033 in it, and we found that there's a file here and here, maybe in here 07.file2, that's got the size 1033. So this works just fine. So if we cat out in here, maybe here 07 file 2, it looks like we have our password and some other white space characters just to pad it up to 133 bytes, presumably. Copy the selection, and we can save our password. And exit and SSH the same thing. I can actually, I'm gonna get, I guess it doesn't really matter. I don't need to, I can leave the super verbose flag. It might just get a little bit annoying. Yeah, I'm gonna remove that. Bandit6 is the right username, right? Yeah. Alright, so level 6 to level 7. The password for the next level is stored somewhere on the server and has all of the following properties. It's owned by user Bandit7, it's in the group Bandit6, and it's 33 bytes large. So this is similar to the last one. We're probably just going to have to narrow it down more specifically. So there's nothing in our directory, which somewhere on the server. Okay, so it's hidden. It's not just in our home directory. It could be anywhere. So we can go to the root of the whole server and look through all of this, right? So we can look back at the man pages, and we can see different options for different things we can do with find, because it's a fairly powerful tool. And one of the things I know we can do is use the -group flag to find if a file belongs to a certain group. So this should help us narrow down files that belong to that group that was mentioned. What was it? Bandit group 6. And what we can also do is use a user flag. I'm going to have to find the next one. User uname, so we can find if a file specified by uname is one of these the file's owner, right? So we're going to run find on /, which means it's going to run from the root of the file system. It's going to look through every file that it has access to read. We're going to put in the group bandit6, and it was user bandit7 is the owner. And this might be enough. So actually we should, it looks like we found it, bandit7.password, but just when we run this from the root of the file system, we're going to get a lot of permission denieds, just because we don't have access to read every single file in the file system, and that's what this command is running through, right? With the /, it goes through the root and goes everywhere. So to remove this, we can actually just use grep again, and similar to the way we use the tool. Well, it's the tool that we used last time. But with grep, you can search for strings and only take specific strings that match the patterns you provide to grep. But you can also omit strings that match a pattern. So with the -v flag, we can type in permission denied, and every string, every line that we get now from this output that includes permission denied will be ignored. Grep v permission. Did I spell something wrong? Let's do permission. The space wasn't escaped, I think, is what happened there. Am I spelling something wrong? Oh, you know what? It's because it's error messages. It's not the standard output. So we have to we would have to redirect the error messages to /dev null, and this should do the trick. Yeah. Okay. So the reason these permission denied statements are actually displayed in a different way that this string bandit7 is .password is displayed. Any binary that you run, so we were running find, has access to a few different files, but a few different output methods. So one of them is the standard output, which is just what we're seeing here in the terminal. And another one of those is the standard error. So error messages will go to a separate pipe. So what we did with that grep, the reason why the grep wasn't working for permission denied is because this grep is looking through the standard output, but the permission denied statements were going through the standard error. So we use this to and this caret, or the sideways caret, this greater than symbol, to redirect to the second output. The 2 stands for the standard error, into dev null. Dev null is the bin bucket. It's pretty much it's a device that's just a trash bin, essentially. So whatever you put in here will go into the void. I just wanted to stop real quick because Trick had a question about what the star doesn't find. And that was just like if we had like -name, we could specify names that we want to find matching a pattern. I put the star there just so it would grab, again, like a wildcard, it would just grab all of the names. Yeah, so this works now that we're redirecting the error messages and ignoring them. And we have that our password is hidden in var lib dpkg info bandit password. So we can just cat this out. /var /lib /dpkg info bandit7.password, and there she blows. Almost missed the H there. Okay, and we can rinse and repeat once more. Bandit7. And we can go back to the website. Yeah, so the difference is between /name and just using the regular expressions is just some tools expect input in different ways. They all kind of manage it in their own formats. So like with cat, what I was doing is cat will expect regular expressions and it'll be able to use that wildcard character to fill in the blanks. But if it wasn't designed to use that star in that way, it wouldn't work. So it depends on what tool you're using, if you're allowed to use wildcards or not, and in what way to use them. So the -name for find is just a similar way to explicitly put that field for that name that you want, the type of, the format of the name you want to find in that option. So bandit7 tells us that the password, that's the wrong one, 7 to 8. The password for the next level is stored in the file data.txt next to the word millionth. Okay. So if we look at our home directory, there's data.txt. And if we cat this out, I'm guessing it's going to be a huge chunk of text. Yeah, it's a huge chunk of text, but it's also in a kind of easy to look at format, right? We see a word, and then we see a password, a string in the form of the passwords we need. So, we could just scroll in here for an hour and try to just look until we find, what was it called? Millionth. So if anybody wants to do that, they can. But we're Linux. There's quicker ways to do this. In fact, using that grep tool we already used is kind of the most straightforward way to do this. So if we cat out this file and what was it called? Data.txt. If we cat data.txt and just pipe this into grep for millionth, this will look through this whole text file until it finds a line that contains that word millionth, and it'll spit it back out to us. There's other ways we can use grep. We can actually provide the file first. I think we can do the file first and then the string. And that'll, actually vice versa. So with grep, you can put the string you want to find and then the file you want to look for, and it'll do the same thing. What I did with the cat is just, to be more explicit with what I was doing, was I was printing out this data.txt and using this line to pipe it into as standard input grep for millionth. Also, if you have a string with special characters with grep, you can put quotes around these strings. It'll work the same way. And the man pages for grep is pretty good too. There's actually a lot you can do with this. So all sorts of different regular expression stuff, line regular expressions. So this is a powerful tool that you definitely should poke around with. So again, I actually didn't even read or copy that, but we need this. And now we're on bandit 8 to 9. The password for the next level is stored in the file data.txt and is the only line of text that occurs only once. Okay, so let's connect to bandit 8. And here I've copied a new line, it seems, which might have been one of the reasons why it wasn't working earlier, but we can ignore that. So we have data.txt. If we get this out again, looks like now we don't have any fancy words to grep for. We just have a bunch of these password strings. And we need to find which of these happens twice. And so I should mention now, and maybe I should have said this earlier, but for each of these, Bandit suggests a few tools. So like for some of the previous ones, we would have found grep and find and cat and these things. But if we look at this now, it looks like there are two things that I know that I want to use, sort and unique. So what sort will do is, if we man sort will sort lines of text files. By default, this is lexiconographically. I think you can provide your own type of order. Again, with any of these tools, there's so many things you can do with them. But if we were to cat data.txt and pipe this into sort, this should, yes. We've piped it into sort, and it has sorted our data and spit it right back out to us. So again, if we just cat it out, we get sort of randomly ordered stuff, and if we just pipe that into sort, it'll sort it. That makes sense, right? So now we need to go through these and find which of these lines only occurs once, right? So I mean, actually, I think I might have found it accidentally just by scrolling. But there's a way that we can do this with tools. So now that unique tool, actually that's man unique, will find lines of texts that are repeated. So we can either show or omit them, but this will find, it'll go line by line and find if any given line doesn't have a repeated one next to it, which is why we need to sort this before running unique. We couldn't just run unique on it because it only checks the one next to it. Otherwise, I don't really need to get into the complexity of it, but if you have to compare each string to each other string, it's a square, a polynomial complexity, not a linear one, right? So we can repeat or omit lines with just the input. I think we can just pipe again straight into this. It should work fine. And we want to report them. No, we want to omit repeated lines. So only print duplicate lines we don't want to do. So I think by default, does it say? With no options, matching lines are merged to the first occurrence. Okay, but we want to omit repeated lines, so dash D, only print duplicated lines, one for each group. Print all duplicate lines. Dash U, okay, U is for unique, only print unique lines. So we want to pipe this into unique dash U. And there it is, USV, whatever. And yeah, so I mean, you can see this actually just by scrolling. We accidentally found it earlier. I don't know, oh yeah, so it's just right here. But you can see that what unique did was it looked through all these lines and it found that, okay, we don't want to print out UJS, V, so on, because there's another one here and here and here and here. But it found this one and it saw that there wasn't a repeating one, and it showed it to us. So we've got our next password. And we can call this bandit9. And we can exit and SSH back into bandit9. Nine to 10. The password for the next level is stored in the file data.txt and one of the few human readable strings preceded by several equal characters. Okay, so if we cat out data.txt, we can see the format of this file. It's a bunch of junk with not many ASCII characters. But there are, equal signs occasionally. What we want to find is text that is preceded by several of them. Right. So what we can do with, and it's actually very useful for a lot of reasons, especially in security. If you're looking through some malware, you want to see some hard-coded strings that are in it. Maybe like an IP address of an attacker or something. There's this tool called strings that allows you to look for ASCII strings inside of big chunks of data. So by default, I think it's, I don't know, maybe like all ASCII strings that are longer than like 5 consecutive ASCII characters or something. But with the -n option, you can provide a number yourself. So we can run strings -n4 over data.txt, and this will show us all ASCII strings of characters 4 or consecutive ASCII characters of 4 or more. So it looks like, this wasn't long enough because we see these are ASCII characters, but this isn't exactly what we want. So let's see if there is a larger number we can use. So maybe 7. We find that, okay, we have equals in password, but we still have a bunch of garbage. So we can actually, let's just grep through this, right? We know grep, and we know we want to look for equal signs. So let's just grep for equals, maybe 3 of them. And here we have the password is, and this is our password. Makes sense, right? So all we did was found the strings of length we found the sequences of ASCII characters. Right, these are just bytes within the certain ranges. So if we go back to the ASCII table, you can actually see that there's different chunks of the ASCII table that are human readable characters. But we find that there are 7 or more of these in sequence. We print all those out, and then we look through those until we find strings that have equals in them, and we print them all out. And here we go. And I'm going to paste this into, I guess this is bandit10, right? Oh, that is a date. I guess I didn't copy the right thing. And just to verify that this password is correct, let's SSH into bandit10. And we're in, so that worked. And it's around time when I said that this event would end. So I think we're going to call it for the day, and I encourage all of you who are still here to continue through these. They're actually really fun, and they get pretty cool, like I was saying. I don't think we really got to any of the too thrilling ones. But there's 15 or so more levels. 27. Yeah, so I think there's like 25 or 26, and then it gets into like Git stuff that isn't too useful for our purposes, what we're trying to teach you guys. Yeah, so it's like Git stuff, but there's a couple dozen more levels for you to explore that I encourage all of you to. But with that, I'm going to ask if anybody has any more questions. I'm gonna, for the next 5 minutes or so, I guess I can hang out, Pog Scream, what will be covered tomorrow. Yeah, so there's another member of the club who is essentially going to be doing the same thing, but they're more going to just answer questions and work hands-on with people. So they expect that those who attend, it's at 2 a.m. The idea there is to line up with India Standard Time. But he's going to expect that participants will have at least watched some of the stream, have gotten their environment set up, and they'll join him on the stream in the same way that you guys are here now, and kind of just work with him as he explains kind of the processes that I went through. Maybe more in depth at some points that I failed to explain thoroughly. So that's kind of how it's going to work. I don't think he expects, the instructor's name is AK, I don't think he expects to cover any further than this, although it'd be really cool if he could. But again, I think the most important part to get out of this is getting Linux set up and learning how to use these tools, because these challenges that we're doing now are very similar, sort of in a way, to the UMass CTF challenges, in that they're going to start really easy and they're going to kind of walk you through it, and then get harder and harder as they go along. So there'll be a lot of repeated learning that'll be reinforced at the CTF that isn't too necessary now, as long as you have the tools available to you. Does that make sense? Yeah. Yeah, I think this was really cool. I'm really glad you guys all showed up. We had, on average, it looked like 17 or so hanging out. So that's hopefully 17 future cybersecurity professionals or something. But having this Linux environment all set up will help you, in hanging out and doing events with us, but also, throughout your undergrad, assuming you guys are undergrads, throughout your undergrad career at UMass, you'll have to use virtual environments to do all sorts of stuff. So kind of just getting ahead of it now is really cool. It's always a struggle at the beginning of each semester. I know, like in operating systems or like 230 and these courses, but the whole first week or two is kind of spent getting a virtual environment set up and running. So if you can kind of get that out of the way, it's pretty neat. Maybe you can hang out for a little bit and get ahead on the actual assignments. I don't know if I want to wait an extra, a minute and 50 seconds to tie it exactly to 2 hours, but I think I'm just going to call it here. Thank you again for joining us. We look forward to seeing you all at our next event. So we're going to, for this UMass CTF prep, we wanted to do more stuff. There's another instructor who wants to do cryptography stuff. That's really cool. I was thinking of doing some malware analysis stuff. So there's plenty more to come. So I hope you had fun, and I hope to see you guys all again soon.